Good morning. This is the second video that I'm making for you. This one is about vector addition. We're going to be looking at how to add two or more vectors to find the resultant vector. So some keys to keep in mind: whenever you're adding vectors, you always want to add them tip to tail. So remember that, tip to tail, and then you want to create your resultant from the tail of the first to the tip of the last. Okay, the resultant goes from the tail of the first to the tip of the last. So just for an example, and again, excuse my fat fingers, I still don't have a stylus, but if we have Susie, let's say she walks 5 blocks to the right, or to the east, I guess we could say, and then she walks, let's say, 7 blocks north. Okay, those are her two vectors. So those are arranged from tip of the first to tail of the second. That's how we arrange those vectors. Then we want to know what was her displacement. So for displacement, that is a resultant vector. The resultant goes from the tail of the first to the tip of the last. So I'm going to label this R for resultant. Now typically we're going to be adding two vectors, but we will see some instances where we're adding more than two vectors. Now just to review, remember we have vectors and we have scalar properties. So our scalar properties are those that don't have a direction, like speed does not have a direction, distance does not have a direction. And then our vectors that we're going to be looking at are things like force, which has a direction, acceleration has a direction, velocity has a direction, and displacement has a direction. So keep in mind the difference, between scalar and vector quantity. Just a real quick question: of the following quantities, which of these are vectors? So the speed of a car. Speed is not a vector. It has no direction. So you can say, I'm going 60 miles per hour. No matter which way you're going, that's your speed. The velocity of your car. Velocity does have a direction. I'm going 60 miles an hour northeast. Okay, that would be a velocity compared to a speed. How long it takes to do a physics assignment. That's going to be a time quantity. Time is always scalar. Okay, you can only go in one direction in time. We cannot go backwards in time. So time has no direction. Okay, it's just assumed. It's a scalar quantity. The magnitude of the force required to push a pumpkin off an abandoned overpass. When you see magnitude, okay, it's kind of like seeing absolute value. Okay, magnitude is just the number. So the magnitude of the force is a scalar quantity. The force itself is a vector because you have to push that pumpkin in some direction. But if we just say magnitude, then it's scalar. And then the acceleration of this said pumpkin would be vector. Is it accelerating down or accelerating up? Okay, that's a vector quantity. All right, so let's look at a few ways that you'll be expected to be able to add vectors. First is really simple. If you have vectors in the same direction. Okay, so here's an example word problem. There's a Nighthawk stealth fighter jet, and it has an airspeed of 1,000 kilometers per hour due east. Now notice this is a velocity. Even though it says airspeed, we have a direction on that speed, making it a vector. So 1,000 kilometers per hour due east, and there's a wind blowing east at 100 kilometers per hour. Calculate the velocity of the jet relative to the ground. So the jet is moving 1,000 kilometers per hour due east, but then the wind is pushing it another 100 kilometers per hour also east. If you have vectors in the same direction, it's really easy. You just add them together. So you don't have to write anything out. If they're in the same direction, let's just add them. So our work would be showing that addition, okay, which I'm not going to write out here for you. But if you were asked to show your work, you would be showing just that you're adding them because they're in the same direction. So our resultant would be 1,100 kilometers per hour. Okay, very simple. Same direction, add. Another thing that could happen is you could have vectors in opposite direction. For example, here we have a ship heading west, and the ship is moving at 15 kilometers per hour. But there is a current in the water that's opposing the ship. The current is moving 3 kilometers per hour to the east. So calculate the velocity of the ship relative to the seabed. So that's going to be your water speed and your ship speed put together. Now, because the water is running in the opposite direction, anytime you have opposite direction vectors, you subtract. So here, the resultant would be 15 minus 3, which is 12 kilometers per hour. Now, which way would the vector be pointing? Well, the vector points whichever one was greatest before you subtracted. So the 15 was greater than the 3 before we subtracted. So this vector has the same direction. So 12 kilometers per hour west. When you answer here, sorry about the baby sounds. When you answer here, you need to be sure to include a direction, okay, which I did not do in that last problem. In the last problem, they were both moving east. Sorry, it won't let me scroll back. But they were both moving east, so our resultant would be to the east. Alright, here's where things start to get a little bit more complicated as when we have perpendicular vectors. So we'll look at two examples here. When you have perpendicular vectors, you have two choices. You can either choose a scale and use a ruler and a protractor to determine your resultant, or you can use trig. Okay, so my preference is to use trig because it's what I'm more comfortable with, but a ruler is just as good, okay, in these instances. And so in this problem, we have a box, and someone is pushing it 500 newtons, that's a unit of force, north, okay? So if I was going to use a scale here, I would say let's make 1 centimeter equal to 100 newtons. Okay, 1 centimeter, 100. Okay, you can choose any scale, but of course I couldn't make 1 centimeter 1 newton because I'm not going to draw a 500 centimeter long line, right? But in this case, I'm going to make one box 1 newton. So 5, 1, 2, 3, 4, 5 to the north. And then another person is pushing 800 newtons east. So tip to tail, remember? So I'm going 1, 2, 3, 4, 5, 6, 7, 8 to the east. Okay, so there's my two vectors that I'm adding together. The question is, what is the resultant? So the resultant is going from the tail to the tip. Okay, here's my resultant. Now I need to figure out the magnitude of this resultant as well as the direction. So to figure out the magnitude, I would take my ruler and measure, and then remember what my scale was, okay, if you wanted to do it that way. The other way is to use trig, so that's what I'm going to show you here. So this side is 500, and this side is 800, and both of these are newtons. Okay, so how can we figure out this side? Well, notice that this is a right triangle, so I can use Pythagorean theorem to determine the value of this side. So I used my calculator. I did 500 squared plus 800 squared and then took the square root of that and found that the value here would be, and I'm going to round this to 3 digits since they gave me 3 digits in my numbers, but I found it to be 943 newtons. Now what about the direction here? Because this is not pointing north and it's not pointing east, it's pointing northeast, a combination of the two vectors that we were given. But we need to know at what angle. And the angle that we want to know is this angle right here that I'm drawing in red. Okay, this is the angle in question. So you can use a protractor and you can measure that angle, okay, if you were drawing to scale. Or you could use trig again and find the angle. Now the only way to use trig though on the triangle is to find these angles inside the triangle. So I could find this angle right here where I'm putting the star, and notice that those two angles add up to 90 degrees. So if I can find that angle in question, then I can subtract it from 90 and find my angle that I'm looking for. So notice this is the angle that I'm going to try to find here. So that would be tangent of that angle, whatever that is equal to, remember tangent is opposite over adjacent, so 800 over 500. Okay, I'm going to use my calculator and find that angle. So 800 over 500. Now I don't know the angle, okay? This is what the tangent would be. So I'm going to click inverse tangent on my calculator, and it tells me that the angle is 58.0 degrees. Okay, that is the angle inside the triangle, but that's not the angle I'm looking for. I'm looking for that angle in question right outside the triangle that I drew in red. So I'm going to do 90 minus 58, and I find that my angle is equal to 32 degrees. So I would say that the resultant vector is 943 newtons at 32 degrees north of east. 32 degrees north of east. Okay, so again, you have two choices. Draw with a ruler. Make sure you choose a scale so you know 1 centimeter equals this. And then you can measure your resultant with your ruler and use a protractor to find the angle, or you can use trig as we just did here. Okay, one more example we're going to look at when we have multiple vectors. Okay, multiple vectors. This is a good time to choose a scale. You can still use trig here, but this is also a good time to use a ruler and a scale. So Justin is going on a fishing trip. Notice the numbers 12, 4, and 1. Okay, that's going to be really easy for me to do on a ruler. I'm going to make 1 kilometer equal to 1 centimeter, and I can just draw these with a ruler. But Justin rides in a boat 12 kilometers south. So take my ruler. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that may not be exact, but you get the idea. 12 south. The fish aren't biting, so he goes 4 west. 1, 2, 3, 4 west. Okay, and then he follows a school 1 north. So 1 north. Notice all these are tip to tail. Okay, so what is my resultant? Okay, the resultant's going to be here. Alright, the question is, what distance did they cover? Now remember, distance is scalar. So distance would just be the total, 12, 4, and 1. He went 17 kilometers in total. But what was his displacement? That's this resultant vector that we'll look at. Okay, so you'll notice what I've drawn in. You may want to pause it to look at that because I paused it to write in. But I wrote in 11, which was the 12 south and the 1 north. That's 11. On that right side, and then 4 along the bottom. And so then I did Pythagorean theorem to find the length of my resultant, 11.7 kilometers. Now if I want to know the angle, I'm going to use tangent again. So the tangent of that angle would be 4 over 11. So in my calculator, 4 divided by 11, and then I press the inverse tangent. That's the one that says tangent to the -1. And it tells me the angle is 20 degrees. Okay, so again though, that's that inside angle, the one inside the triangle. Okay, right there, 20 degrees. But I want to know this angle right here. Okay, and so those add up to 90, of course, so that's 70 degrees. So I would say that my resultant is 11.7 kilometers, 70 degrees southeast. Southeast. Okay? Oh, excuse me, southwest. Those two together. Southwest. Alright, hope that makes sense. Sorry about the screaming baby. Let me know if you have any questions.